Assalamualaikum and good day everyone. Before we proceed with the example 4.2, I hope all of you have already watched the previous video on the two-way ANOVA test. Today we are going to test our knowledge by answering example 4.2. Now let's look at example 4.2. A chemical engineer studies the effect of various reagents and catalysts on the yield of a chemical process. The yield is expressed as a percentage of a theoretical maximum. 2 runs of the process are made for each combination of 3 reagents and 4 catalysts, and the data is given as follows. So, as we understand from this question, we have 3 different variables. Number 1 is reagents, number 2 is the catalyst, and number 3 is yield of a chemical process. So, which one is the independent and the dependent variable in our question? So, as we can see that the yield of a chemical process is depend on the various reagents and the catalyst. So, that means the reagents and the catalyst is the independent variable and the yield of the chemical process is the dependent variable. Next, we look at the table below. In the table, the catalyst is at the row and the reagent is at the column. So that means catalyst is factor A, also known as the row factor, and the reagent is the factor B, also known as the column factor. So factor A have 4 different levels, 1, 2, 3 and 4, because we have A, B, C and catalyst D. Reagent have 3 different levels, level 1 for region 1, level 2 for region 2 and level 3 for region number 3. From this question also, it is mentioned that 2 runs of the process are made for each combinations. So that means for each treatments we have, for example, treatment A1, we have 2 replications. The first one is 86.8, the second replication is 82.4. The next treatment we have A2 and the data is 93.4 and 85.2, and then the next replication is A3, B1, B2, B3, C1, C2, C3 until the last replications, the last treatments, which is the D3. So, from our understand, R equal to A equal 4 and B equal 3. This value is really important for us when we want to find our F alpha value later. Now we go to the question. A. Write down the appropriate ANOVA model for the given data and state the assumptions and the rules. B. State the independent and the dependent variable. C. Identify the factors involved in the study. D. How many treatments involved in this experiment? List all the possible treatments. How many replicates for each treatment? E. Construct an ANOVA table. And F. Test if there is an interaction effect between reagents and catalysts on the yield of a chemical process at 5% significant level. So this is the solution for A. You can answer the question for A by looking at the notes in your module. The general model is mu plus alpha I plus beta j plus alpha beta ij plus epsilon ijk. And then please state all the assumptions, all the 6 assumptions for the two-way ANOVA model. And then we have 2 rules for these questions. For question B, we already answered the independent variable is the catalyst and reagent, and the dependent variable is the yield of a chemical process. So that means for C, the factor involved in the study are catalyst and reagent. To answer question D, there are 12 treatments involved in this experiment. So the treatments are catalyst A and reagent 1, and then we have A with reagent 2, and then we have A with reagent 3. And then we have B1, B2, B3, C1, C2 and C3, D1, D2 and D3. So the total treatments is 12 treatments. And then the number of replication is 2. To construct the ANOVA table, first we must find the summation for each rows and each columns. So as you can see, this is the summation for the first row, second row, third row, and the fourth row. And then we also have the summation for the first column, the second column, and the third column. This is the total for all data. And then we also need to find the summation for each replications. So the first replication have 169.2 total. And then the second treatment, we have total 178.6. And then we also have the third treatment, we have the total 167.5 until the last treatment, which is the 155.5. So as we already know, factor A has 4 level, factor B has 3 level, and we have replications equal to 2. Now we want to find the summation square value for A, B, AB, total, and for error. So the first one we want to find is SSA. So SSA equal 1 over BR, which is 3 multiplied by 2, multiplied by, this is the summation for row number 1, row number 2, row number 3, and row number 4. And then don't forget the square value, minus the big total square over A, B, R, and then you will have 683.4900. This will be our SSA. The next one is the SSB. SSB equal 1 over AR, which is 42, and then this is the summation for the first column, second column, and the third column. And then also don't forget the square value. Okay, minus 186.4, the big total here, over A, B, R, and then you will have your answer 263.4775. Next, we move on to the SSAB. SSAB equal 1 over R, which is 2, multiplied by This is the summation for the first interaction, first treatment, the second treatment, until the last treatment. Also, don't forget the square value. Minus big total over ABR, and then minus, this is SSA minus SSP, and then your answer is 138.7825. Next, we move on to the SS total. SS total equal 86.8 square. This is the data for the first run, second run, and then until the last data you have 5.7 square minus big total again square over ABR, and then you will have your answer is 1440.0400. The last one will be the SSE. SSE equal SST minus the SSA minus the SSP minus the SSAB, and then you will have your answer 354.29. After we finish find all the sum square value, so we fill the value into the first column. Now we move on to the second column, degree of freedom. So the first row will be the A minus 1, and then we have 4 minus 1 will be 3. The second row we have B minus 1, which is the 3 minus 1 equal to 2, and then the third row will be A minus 1 multiplied by B minus 1, which is the 3 multiplied by 2 equals 6. For the error, degree of freedom is ABR minus 1. So we have equal 12. And the last one for the total degree of freedom is ABR minus 1, and then we have 23. Now we move on to the third column, mean square. After we finish the first and the second column, we can find the third column. So for the MSA, 683.49 divide 3, and then you have 227.8300. For the MSB, 263.4775 divide 2 equal 131.7388. For the interaction effect, we have 183.7825 divide 6 equal 23.1304, and the last mean square for error is 354.29 divide 12 equal 29.5242. After we finish with the mean square, now we can find the f-test for each of the variable. So for the first one, f-test for A, 2 to 7 here, divide the MSE 29.5242, and then you can have the 7.7167. For the f-test for P, 131.7388 also divide with the 29.5242, and then you can have 4.4621. The last F test is 23.1304, also divide 29.5242, and then you can have the 0.7834. For the critical value, I think you don't have much problem to find all the value for the F alpha from your statistical table. Make sure you find the correct value in your table. Now we finish with the ANOVA table, and then we can proceed to the analysis part. Next one, to answer question F, the first hypothesis test we want to have is for interaction effect. So your H0 is there is no interaction effect between catalyst and reagents. H1 is there is an interaction effect between catalyst and reagents. So in step 2, your F alpha is 2.9961, and then when we compare your F test with your F alpha, you can see clearly that your F test is smaller than F alpha. So that means your decision is do not reject H null or accept H null. So for your conclusion is at alpha 0.05, there is no interaction effect between catalyst and reagents on the yield of chemical process. So as we understand before, when there is no interaction effect between factor A and factor B, so we must proceed with the marginal effect. Since there is no interaction effect between factor A and factor B, so now we must proceed to the marginal test. The first one is for the row effect. Your H0 is there is no effect of catalyst. Your H1 is there is an effect of catalyst. So from your statistical table, your F alpha is 3.4903, and then we will compare our F test with the F alpha. So you can see that your F test is larger than your F alpha. So you can see clearly that this is your F alpha 3.4903, and then this will be your rejection region. Your F test fall into the rejection region because it is larger than your F alpha. So that means your decision is reject null. So for our conclusion is at alpha 0.05, there is an effect of catalyst on the yield of chemical process. After we finish with the row effect, next we move on to the column effect. So your H0 will be there is no effect of reagents. Your H1 is there is an effect of reagents. And then from your statistical table, your F alpha is 3.8853, and then as usual we will compare your F test with your F alpha. So you can see that your F test is also larger than your F alpha. This is your rejection region, and then your F test fall into the rejection region 4.4621. So your decision is clearly reject null. And lastly, for your conclusion is at alpha 0.05, there is an effect of reagents on the yield of the chemical process. So this is how you answer example 4.2 using two-way ANOVA test. I hope all of you can test your knowledge on two-way ANOVA test by answering exercise 4.3. Until we meet again in the next video. Bye.